Welcome to Data Engineers Academy, and this is part 2 of our video. In part 1, we built the full Snowflake pipeline plus Streamlit dashboard. In this video, we are going to automate met statements using tasks. Okay, it is comes straight from a viewer suggestion. Let's go into this. For this, we have to create one database. Name it banking DB and three schemas, naming raw, core, and app. The purpose of these three schemas is for the first layer, raw layer, it is a landing zone where data comes in exactly as is, no cleanup yet. Okay, and in core layer, this is where we build proper dimension and fact tables, clean types, primary keys, and the real analytical model. And in the third app layer, which we will build out later for reporting. Okay, think of it like a funnel. Messy data goes in one end, structured data comes out the other. Let me create this. Create database. Since I have already created this, it is showing like already exists. For you people, it will be shown like created. Next, I am going to create schema. Just run this statement. It is already existed. And next, run ender schema. Okay, I have created database and three schemas. Next, I am using this database. Name it banking DB, right? Next, I am using the schema raw. As I told you, the purpose of raw layer is it is a landing zone where data comes. There is no cleanup at just a raw data. So we do that with a storage integration, like basically a secure bridge between Snowflake and our bucket in GCS bucket. Once that created, Snowflake hands us a service account. I will show you. Let's run this. I will create a storage integration. Okay, successfully created. Here the type is external stage because I am bringing data from GCS, and I have given here my bucket path. I will show you. This is my GCS console, and here just type buckets. I have created a bucket here. Let's wait. If you want to create a new bucket, you can use this icon and create a bucket. And here my bucket name is my banking dashboard, right? So I have given this path there. It's that simple. Okay. And next, mm, here what we will do is we copy the data. We copy that into GCP and grant it viewer access on the bucket. Here the service we need GCP service account. So describe integration. We have to use this command to get service account. So here we get this is storage GCP service account, and this is the URL. Just copy it, and we have to give permission in GCS. So again go to GCS, just give here IAM. Go to this. Just we have to grant access to that service account. I'm going to do that. Yeah, it's loading. Just wait. Yeah, here we get. So I have to go to grant access and I have to paste here. We will get here like this. Click on that. Here we have to okay access a role named storage object viewer, right? So storage object viewer. type here storage object viewer. Here, click on this and just simply create, sorry, save. As I have already grant access on that, it is showing like principal already exists on this policy. So next, so the channel between a Snowflake and GCS is created. Next, we are going to create a file format. That means we have files like CSV, JSON, etc. Right? Here I am using CSV file. The file I am giving the file format name like CSV FF. Okay, in banking DB database raw schema, I am creating a file CSV FF. Type is CSV, and next here we are creating a stage. In stage layer, that means here we are in a stage named GCS stage, and the storage integration name we have given is GCS integration, right? We have created storage integration name GCS integration. So I am giving here and my bucket path, and the file format is CSV FF, right? You can give the name whatever you want, but type must be CSV. Next, so here we can list the tables. Just a minute. Integration GCS does not exist or authorized. Just run this. Yeah. Now the file is successfully created. Oh, it's showing error. File format CSV does not exist or authorized. Okay, let me fix this. Now the error is that stage references without schema qualification. Okay, we have to mention the database name and schema also. Okay, we will keep that and run. Okay, now whatever the files we have uploaded in GCS bucket will be reflected here because we have created a stage. We can see here the storage integration name is GCS integration. That means we have created a channel between Snowflake and GCS, right, using storage integration. So through that integration, using the bucket path, it will be landed into our stage. Okay, I'm just giving here file format name. So we will check whether it landed or not. Yeah, if you see here, the customers.csv file get uploaded here. The total record, the size is 950. Okay, like that all will be coming to the stage. Okay, branches. Next, so files are successfully landed onto a stage, and next I am creating a table in raw layer only Just I'm creating a table named stage customers. Already exists. It will be like created for you people. It will be displayed like created. And next, I'm creating another table stage accounts branches, stage branches. Here observe I'm using database and schema and then table name. Here I have to create table as per the schema in GCS bucket tables. They have to match. Okay. Here now I have created all stage tables. All next I'm going to use schema core. Okay. What will we do in this core layer? This is where we build proper dimension and fact tables, clean types, etc. So I'm going to create dimension table. Name it dimension customer, dim customer. Here my primary key is customer ID and next account, dim account, branch. And now I'm going to create fact tables. This process is like in part 1 only. Okay, I am created all fact tables and dimension tables. Now I am going to create a procedure. Okay, I'm for that I am using raw schema. Here's the part that actually does the work. For each dataset, we have written a stored procedure that does three things every single time it runs. One, it copies fresh files from the GCS stage into the raw staging table. And second, it merges that staging data into the core table. And this is the key idea. It's a merge, not just an insert. That means if a customer already exists, we update their details. If they are brand new, we insert them. No duplicates, no manual cleanup. And three, once the match is done, it clears out the staging table so it's ready for the next batch of files. So I am creating procedure, name it proc load match customers. Okay, we can see here I am copying into stage customers from the GCS bucket and the file format, and then I am merging into the core dimension tables using this. Okay, you can see here on the condition customer ID tgt dot customer ID is equal to src dot customer ID. When matched, update. When not matched, insert. Okay. Likewise, I am creating procedures for load merge accounts and then load merge branches and next load merge transactions and next load merge balances. Okay, I have created procedures here and next step is now use role account admin for creating warehouse. I am creating a warehouse naming banking warehouse and the size is small. Auto assessment 60 seconds, that means 1 minute. Auto resume true. Use schema, raw schema, and I am creating a task here. This is the main part. So I am scheduling it for every 2 minutes. If you want, you can give for 1 year, 1 day, 1 month, etc. So I am using tasks here for each procedure. You can see here the load merge accounts. We have created procedures, right, For suppose if you see here, just the name proc load match balances. Okay, so just I'm creating a task for that for every procedure. Okay, task is created here. Okay, and then next task is creating for every procedure. Just am resuming all the tasks. Okay, let's see if the task created or not. Yeah, we can see here we have 5 tasks. Just I am calling. Yeah, we can see here customer load plus merge completed. Likewise, we have to run all these. It's done. Then now to guest next one. Yes, it is also done. Next. So all was set. Just view the data. Okay, I am viewing data from dim customer. We have got data. Okay, now if we want to see in dashboard, we have to go to Streamlit. That means if we go here, we will get an option like Streamlit. Okay, create. Here in tasks, what we did is manually running 5 procedures every time new data lands is not exactly scalable. So this is where Snowflake tasks. This is where Snowflake tasks are running on their own. Like we spin up a small warehouse to power the work, and then wrap each procedure in a task with its own schedule. In this case, running automatically every couple of minutes. Okay, once we resume these tasks, the pipeline is basically alive. New files show up in the bucket, and within minutes they are loaded, clean, and matched into the core tables, completely hands off. So we can see the updated data. We will get like this. Just remove all the data here and paste the code I will be providing. Yes, the code, it will be like this code. It is in Python. Just run this code. I will be providing you. So in transaction start date 2024 June 1st, we can see data. Key metrics: total transactions are 20, total deposits are $7,700, and withdrawals are $750. Tra- Transaction type, we can see here: deposit, transfer, withdrawal, and all the information, whatever you want, you can access here. For example, if I want from data from date 30, I can give. Okay, the new data. Okay, previously we have 7,700 US dollars seen, right? So here total transactions are 7 in that day, and total deposits, total withdrawals. Likewise, we can see here all the data, the transaction type and all. So that's the full pipeline from raw files in cloud storage to a fully automated, self-updating banking data warehouse in Snowflake. If you found this help useful, drop a comment and I will see you in the next one. Thank you.